Hi, so we'll discuss proportions. Now, what is a proportion? We have seen ratios in the last lecture. Proportion means, so this is how you denote proportion with two columns. If A is to B is in proportion with C is to D. Okay, that means if two ratios are in proportion, will imply that the two ratios are equal. It's as simple as that. Proportion means two ratios are equal. If two ratios are equal, they are in proportion. For example, I can say that 1 is to 2 is same as 2 is to 4. Isn't it? 1 is to 2 and 2 is to 4, they are both same. So I can say that 1 is to 2 is in proportion with 2 is to 4. Now this is in proportion with, let's say, 10 is to 20. So there can be infinite such values. So the basic idea of proportion is that the ratios are same. If two quantities, let's say, now what are the applications of proportions? Okay. Before that, we'll solve a question. If 7 is to 6 is in proportion with y is to 144, find y. So we have seen this is straightforward. The ratio of 7 and 6 is same as the ratio of y and 144. We'll cross multiply. We get 7 into 144 is 6 into y, or 6 into y is 7 into 144. We divide by 6 and you can calculate. You'll get the value of y as 168. This is a basic example of how you can solve proportion. So remember, proportion means the ratio is constant. Now, there are two types of proportions. Now, what is directly proportional? Let's say if two quantities A and B are directly proportional to each other. Okay, in the previous ratio we have seen that 1 is to 2 is in proportion with 2 is to 4, right? Let's say 1 and 2 are proportional with 2 and 4. If corresponding one value is increasing, the corresponding 2 value is also increasing. Okay. Similarly, in directly proportion, what happens whenever one value increases, the other value increases. So that is when they are called directly proportional to each other. One classic example is distance traveled and speed. Okay, we know that the distance formula is d is speed into time, right? Now important is when we are comparing distance and speed, we'll need to keep the other constants, other variables as constant, sorry. So time you will keep it as constant. Now we know that if the speed increases, the distance traveled will also increase for the same time. Okay, so this is a classic case. Let's say for 1 hour, so t is 1. If speed is 50 miles per hour, so what is the distance traveled? It will be 50 miles in 1 hour. Similarly, if speed is 100 miles per hour, what will be the distance traveled? 100 miles. Now here, if you'll observe the ratio of distance and speed, which is be it 50 upon 50 or 100 upon 100, the ratio will always be equal. So directly proportional is similar to the normal proportion, where if two quantities are given, their ratio is always a constant. So I can take that A upon B as a constant K. K is any constant. Now, inversely proportional. So there is another way that directly proportional is denoted. This alpha kind of symbol is used. If this is used, you can know that they are directly proportional. They are directly proportional, the ratio is constant. So the same way they will give some condition to find k, and then you can get the answer basically. Now, inversely proportional, let's say if A and B are inversely proportional. Again, the classic example is speed and time, right? Speed and time, we know that the formula is this. Now, distance is constant. You have to ensure that the other variables are constant. So let the distance is 100 miles. For 100 miles, if speed is 50 miles per hour, so how much time will it take? Time is distance upon speed, right? Which is, it will take 2 hours. Now let us increase the speed to 100 miles per hour. So how much time will it take now? When the speed is increasing, the time taken is decreasing. So this is what is inversely proportional means. Okay, in directly proportional, when one value increases, the other value will increase. In inversely, if one value increases, the other value will decrease. Now, if you see, what is common here is that the speed into time is always constant. When speed was 50, time was 2, and when speed was 100, time was 1. So if two quantities A and B are proportional, you will say that A multiplied by B is a constant. A into B is equal to K, where K is any constant which you will need to find using the information given in the question. So these are the only two things that you will need to remember. Directly proportional, A upon B is K. Inversely proportional, A multiplied B is K. So we'll solve one or two questions. If Y is directly proportional to X, so I know that Y upon X is K. Okay, directly proportional, ratio is K. Inversely proportional, the product is K. And Y is equal to 5 when X is equal to 2. So they have given when Y is equal to 5, X is equal to 2. So we can substitute and find the value of K. So K is 5 by 2. They will give a condition to find the value of K. So Y upon X becomes 5 upon 2, right? Once you find the constant, you can substitute. And they're asking, what is the value of Y when X is 16? So we have this Y upon X is 5 upon 2. So take 16 to the other side and simplify to get the value of Y. Step 1, most of the times, is to find the constant K. And step 2 is they will give one of the values and ask you to find the other values. Straightforward questions will be asked. Okay, one last question. The cost of a watermelon is proportional to square root of its weight. So two things. One is that they're saying proportional. When they're saying proportional, you always take as directly proportional. Unless otherwise mentioned as inverse, you take it as direct. Here, it's not A and B, it's A and square root of B. Now, what is A here? A is the cost and B is the weight. Okay, A is cost and B is weight. But cost is proportional to square root. This is where you have to be careful. So what is constant? A upon square root of B is constant. Directly proportional, the ratio is constant, but not ratio of A and B, ratio of A and square root of B. If a watermelon weigh means B is given as 16. When B is 16, A is 50. So 50 upon square root of 16 is K. So K is 50 upon 4. We can cancel in 2. So K value is 25 upon 2. So what we got is A upon square root of B is 25 upon 2. Now, how much will a watermelon be? Watermelon costing $37.5. Watermelon costing $37.5, weigh in pounds. Okay, so this is in pounds only, B. So when A is 37.5, what is the value of square B basically? So quite calculative, as we can see. 37.5 into 2. Okay, so 37.5 into 2, if you calculate, 10s, 14, 1, 15, 1 carries, 2 3s are 6 plus 1, 75. Okay, so 25, root B is 75. So you divide by 25. This is 3. Now how to get B? We have seen you square on both sides. There is a square root. You square on both sides to get the value of B. So B, because square root and square gets cancelled, this will be 9 pounds. So the same way you will solve any type of question, be it directly proportional or inversely proportional. So that's it about proportions, and I'll see you in the next video. Thank you.